An elimination reaction is a large class of reactions. You do it when you have something on a molecule and you just want it gone. You don't want it substituted with something else. You don't want it replaced by something else. So you wouldn't do a substitution reaction. You just want that group gone. You want it to act like a leaving group and leave. So you will need to have some sort of leaving group leaving. That's one thing that's clear. And that is one of the key steps in an elimination reaction: loss of a leaving group. But how do you kick the leaving group off? How do you get it to leave and stay off? In substitution reactions, you got it to stay off by replacing it with another nucleophile. You get another nucleophile to come in and it takes its place, so the leaving group wouldn't ever come back. And in an SN2 reaction, the nucleophile kicks it off. Well, what will take its place in an elimination reaction if we don't want to add something new to this molecule? It has to be something that's already on the molecule. And those are going to be electrons. They're going to be electrons already on the molecule. Now, the leaving group, the carbon that the leaving group is attached to, is described as the alpha carbon. Alpha is the first letter in the Greek alphabet. The word alphabet comes from the first two letters in the Greek alphabet, alpha and beta. So the first carbon that's attached to the leaving group is described as the alpha carbon. The carbons right next door to it are described as the beta carbons. So the first two carbons closest to the leaving group are described by the first two letters. The beta carbon could have a hydrogen on it. And so those hydrogens are described as beta hydrogens. It is the electrons that are going to the beta hydrogens that are ultimately going to kick the leaving group off in an elimination reaction. What we want to do is to snatch that hydrogen away, steal it, and then the electrons will be left to push the leaving group off. Now, if we want to remove a hydrogen from a molecule, we need a molecule that is going to accept that H+. Well, a molecule that accepts an H+ is a base. Bases accept protons. They accept H+. So the base can steal the hydrogen. Notice this is going to be a proton transfer. And the electrons that were keeping that hydrogen on the molecule can go to kick the leaving group off. So this second curved arrow pattern is proton transfer. So if you do that, then you'll still have the same number of carbons, but now you will have this pi bond here. And the leaving group will be off living its best life. So notice what happened. You took a substrate, you treated it with a base, and you got an alkene. You eliminated a leaving group, you turned an alkane with a leaving group on it into an alkene. You created a pi bond. And the two essential steps to make this happen are loss of a leaving group and proton transfer. Now, when you eliminate something from a molecule, it's an elimination reaction, and so it's classified with a capital E. In the reaction that I've drawn, our two steps, loss of a leaving group and proton transfer, those two things happen at the same time. And because of that, a 2 is included in the classification. So this reaction that we've drawn is described as an E2 reaction. The mechanism of this is an E2 mechanism. You have loss of a leaving group and proton transfer happening at the same time. Compare this with an SN2 reaction. SN2 also had loss of a leaving group, but instead of proton transfer, it had nucleophilic attack. So notice that difference. In substitution, you have a new molecule, the nucleophile, coming in. In elimination, you don't have a new molecule coming onto the substrate. You just have a base stealing a hydrogen off so that the electrons that are already there can give the boot to a leaving group. So that's elimination, that's E2. And you could imagine having that same mechanism, those same two steps, happening one at a time. So for example, you could imagine having the leaving group leave as one first step that happens all by itself. You could have a carbocation intermediate, and then you could have a base as a second separate step. You could have a base steal the beta hydrogen. Right, remember, the carbon that has the leaving group on is the alpha carbon, next door is the beta carbon, and the hydrogens that are on that carbon are called the beta hydrogens. So if you have that, then the electrons that were keeping the hydrogen there can go to stabilize that positive charge. And so you still form that alkene. Now in this case, it's still an elimination reaction. You had something on the molecule, it's not there anymore. So you're still eliminating things, so big E, but only one curved arrow pattern happens at a time. First, you have loss of a leaving group, and second, separately, you have proton transfer. Because only one thing happens at a time here, this is classified as an E1 reaction. So elimination reactions take a leaving group off the molecule and create alkenes. And they do that with two key crucial steps, loss of a leaving group and proton transfer. There are two types of elimination reactions, E2 reactions, where loss of a leaving group and proton transfer happen at the same time, and E1 reactions, where loss of a leaving group happens in one step, and then in a second separate step, you get proton transfer. So this is just a small, short, quick introduction to elimination reactions. We'll be drawing the mechanisms for them for a bunch